The integration of decentralized AI with SASE architectures represents more than a technological evolution. It embodies a fundamental shift toward a more democratic, responsive, and privacy-preserving intelligent infrastructure. By distributing AI capabilities across network edges while maintaining unified security and management frameworks, organizations can achieve the benefits of advanced intelligence without the risks and limitations of centralized control. This transformation promises to democratize access to AI capabilities, enable new forms of collaborative intelligence, and create a network infrastructure that becomes more valuable and capable over time. As these technologies mature and converge, they will likely reshape not only how we think about network security and management, but also how intelligent systems can serve human needs while respecting individual privacy and autonomy. The future belongs to networks that are not just connected, but truly intelligent systems that can learn, adapt, and collaborate while maintaining the trust and security that modern organizations demand. The convergence of decentralized AI with SASE represents a crucial step toward that future, offering a pathway to intelligent infrastructure that serves everyone. Blockchain-powered AI infrastructure. Blockchain technology is emerging as the foundational infrastructure that makes truly decentralized AI possible, creating trustless networks in which computational resources, model training, and data sharing can occur without central authorities. Unlike traditional cloud computing, which relies on centralized servers controlled by technology giants, blockchain-powered AI infrastructure distributes computational workloads across thousands of independent nodes, each of which is verified and incentivized through cryptographic protocols. This architecture enables AI training and inference to occur on a global scale, while maintaining transparency, security, and democratic governance over the underlying systems. The economic model driving this transformation is fundamentally different from the traditional AI infrastructure. Participants in blockchain-powered networks earn tokens for contributing computational resources, storage, or data, creating a marketplace in which AI development becomes financially accessible to smaller organizations and individual developers. Companies like Manifold are pioneering this approach, recently completing a $10.5 million Series A funding round to scale their blockchain-powered AI infrastructure, marking what industry observers describe as a significant shift toward more transparent, scalable, and community-incentivized AI development. This infrastructure addresses critical vulnerabilities in centralized systems by eliminating single points of failure and creating immutable audit trails for AI decision-making processes. Smart contracts automatically execute resource allocation and model training protocols, ensuring that no single entity can manipulate outcomes or access sensitive data without authorization. The result is an AI ecosystem in which computational power is distributed globally, model governance is transparent and democratic, and economic benefits flow to contributors rather than concentrating on corporate coffers. Open source model communities. The foundation of decentralized AI rests on vibrant open source model communities that have transformed AI development from exclusive corporate laboratories into collaborative ecosystems that are accessible to millions of developers worldwide. Unlike proprietary models locked behind corporate walls, open source alternatives such as Llama, Bloom, and GPT-NeoX have democratized access to state-of-the-art AI capabilities, with some achieving ChatGPT quality of over 90% at development costs as low as $300. As these communities operate on fundamentally different principles from traditional corporate AI development. Contributors span across academia, nonprofits, and smaller research labs who collectively advance models through transparent, community-driven innovation that leads to rapid advancements impossible with closed-source approaches. Bloom exemplifies this collaborative spirit, emerging from massive international research collaboration specifically designed to democratize access to large language models for institutions that previously could not afford proprietary alternatives. The model supports 46 natural languages and 13 programming languages, breaking down the linguistic barriers that often limit corporate AI solutions. The community-centric approach extends beyond mere code sharing to create genuine product ecosystems around open models. Hugging Face has become the central hub for this movement, providing infrastructure for millions of developers to collaborate on models, data sets, and applications through their comprehensive toolkit, including transformers, data sets, and text generation inference. This platform demonstrates how open source communities can rival corporate resources, offering everything from parameter-efficient fine-tuning libraries to browser-based ML executions. What makes these communities particularly powerful is their alignment of technical innovation with economic democratization. Open source models eliminate per-token pricing, which can cost organizations thousands of months in commercial deployments, while enabling complete customization for domain-specific applications. Organizations gain full control over their data processing, deploy models on private infrastructure to ensure compliance, and avoid vendor lock-in scenarios that tie them to specific providers for updates and support. This economic freedom, combined with code transparency that enables detailed audits and bug fixes, creates sustainable alternatives to corporate AI monopolies, which grow stronger through collective contributions rather than centralized control. Corporate AI monopoly breakdown. The stranglehold that tech giants currently maintain over artificial intelligence is beginning to crack under pressure from both regulatory scrutiny and technological disruption. While Google controls over 90% of search-related AI queries, and major players such as OpenAI, Google, and Meta capture more than 80% of the $500 billion AI market, this dominance faces unprecedented challenges that signal a fundamental shift in power dynamics. The most visible cracks appear in the search landscape, where AI-driven platforms are rapidly eroding the traditional market boundaries. ChatGPT now commands an estimated 80.1% share of the AI-driven search market, fundamentally altering how users interact with information retrieval systems. This represents a seismic shift from keyword-based queries to conversational interactions that bypass the traditional search gatekeepers. Microsoft's integration of OpenAI technology into Bing, combined with Google's scramble to embed AI overviews directly into search results, demonstrates how established monopolies are racing to adapt rather than dictate the market evolution. Patent concentration reveals another vulnerability to corporate AI dominance. Although 70% of AI patents are held by just 10 companies, creating what economists term a knowledge monopoly, the open source movement systematically undermines this intellectual property advantage. The collaborative development model, pioneered by projects such as Bloom and supported by platforms such as Hugging Face, proves that distributed innovation can match or exceed corporate R&D capabilities at a fraction of cost. Regulatory pressure intensifies across multiple jurisdictions, with the DOJ's Google search antitrust case serving as a bellwether for broader AI monopoly concerns. The Department of Justice has begun warning that Google can replicate its exclusionary tactics in the AI space, seeking to prevent exclusive distribution agreements for AI tools and applications. This regulatory awakening comes when policymakers recognize that concentrated AI control poses risks to innovation, competition, and democratic governance. The economic model that sustains these monopolies also shows signs of strain. Traditional AI development requires massive capital investments in data centers, specialized hardware, and proprietary data sets, barriers that once seemed insurmountable. However, blockchain-powered infrastructure and tokenized incentive systems create alternative pathways that distribute both costs and rewards across global networks of participants. This shift transforms AI development from capital-intensive corporate activity into a community-driven endeavor in which computational resources, data, contributions, and model improvements can be monetized directly by contributors rather than extracted by intermediaries. Perhaps most critically, the philosophical foundation of corporate AI monopolies, in which centralized control enables superior products, is being challenged by evidence of systematic bias, privacy violations, and algorithmic manipulation. Real-world consequences include AI hiring tools discriminating against ethnic minorities in 25% of cases, and centralized data silos becoming targets for both hackers and authoritarian surveillance. These failures create an opening for decentralized alternatives that promise transparency, democratic governance, and alignment with users rather than shareholder interests. Smart contract AI orchestration. Bright contract AI orchestration represents the convergence of autonomous AI agents with blockchain-based execution frameworks, enabling complex multi-agent systems to coordinate seamlessly without centralized oversight. Unlike traditional AI orchestration, which relies on centralized platforms, blockchain-powered systems use smart contracts as the coordination layer to automatically manage resource allocation, task distribution, and value exchange between AI agents across distributed networks. Fetch.ai exemplifies this integration through its Layer 1 blockchain platform, specifically designed for autonomous software agents and AI-driven applications. This platform enables AI agents to function as digital twins that negotiate, transact, and execute decisions based on real-time data and embedded AI models. These agents operate within an open economic framework in which smart contracts facilitate microtransactions, prevent Sybil attacks through token collateral, and unlock specialized services automatically based on predefined conditions. The orchestration process transforms how AI agents discover and collaborate. Rather than requiring human-defined workflows, smart contracts enable AI agents to reason autonomously through complex task allocation. When an AI agent requires specialized capabilities, whether for data processing, model inference, or external API integration, smart contracts can automatically identify suitable agents, negotiate terms, and execute payment transfers using native tokens. This creates self-organizing agent swarms, where coordination emerges from algorithmic interactions rather than centralized management. Token-based incentive mechanisms fundamentally alter the economics of AI collaboration. Platforms such as the Render Network, RNDR, demonstrate how smart contracts can automatically distribute rewards to computational contributors based on verified AI workload completion. This eliminates traditional intermediaries that capture value from AI services, instead ensuring that rewards flow directly to the nodes, providing actual computational resources or specialized AI capabilities. Bright contract orchestration also enables sophisticated automated asset management strategies that respond to real-world data feeds. Through Oracle networks such as Chainlink, AI agents can execute trading strategies, rebalance portfolios, or trigger revenue-sharing distributions based on external market conditions or performance metrics. Pickle Finance uses this approach in its automated liquidity provision system, where smart contracts continuously optimize capital efficiency across decentralized exchanges without human intervention. However, significant technical challenges remain to be overcome. The stateless nature of most smart contracts prevents on-chain learning or persistent AI behavior, forcing most AI computations to occur off-chain while using only blockchain for coordination and payments. This hybrid architecture limits complete decentralization because the core AI functionality remains opaque and unverifiable in the chain. Despite these limitations, emerging Layer 2 solutions and AI-dedicated blockchains with native GPU support hint at future architectures that could enable verifiable AI computation at scale. Federated